Hi, I'm Jake, one of the co-founders of AuthZed, the creators and maintainers of SpiceDB, the open source relationship-based access control system. I also have the distinction of being the author of the very first lines of code of SpiceDB. In this course, I'm going to teach you about the primitives that you can use to build schemas in SpiceDB to capture all of the complexity and nuance of the way permissions work in your application. We'll learn about concepts such as relationships, algebraic set operators, and caveated relationships. By the end of this course, you should have all of the information that you need and all of the tools in your tool belt to be able to create simple permissions models for your application. Enjoy! So I'm going to start with relationships. Because SpiceDB is an implementation of relationship-based access control, relationships form the fundamental piece of data for how we think about all permissions and all data in SpiceDB. So to explain it visually, I'll talk about a relationship and what the various components are and what all relationships have in common. So first of all relationships relate one object to another object. So we'll start with that. So these are my two objects. And then this arrow will represent how the objects relate to each other. So in our specific case, we're going to talk about a resource called quarterly planning. That's a document. And then we'll talk about a user named Jake, who has access to the quarterly planning. We'll also say that Jake has reader access to quarterly planning. We call this part of a relationship the relation. So to recap, we have objects, right? So both quarterly planning and Jake are objects. Quarterly planning is a resource. So it forms the resource component of a relationship. Then Jake is the subject of the relationship. And then reader is the relation. And so the two ways to read this relationship are, we could say that quarterly planning has a reader of Jake, or more naturally, we could say that Jake is a reader of quarterly planning. We always start from the resource and move toward the subject in any relationship-based access control system. Now that we understand relationships, the next step is to talk about how we can model relationships and schema together to create a permission system in SpiceDB. So switching over to our playground, we can see that the sort of base case schema includes an object definition for a user. If we want to recreate the relationship that we had in our relationship video, we also need an object definition for a type of document. And we need to say that a user can be a reader of a document. So we'll start by adding an object definition for document. And then inside that object definition, we'll define a relation. Again, the relation that we created before was called reader. And then we're not quite done because we also need to define the types that can be a reader of this document. So in our case, we want to allow users to be a reader of the document. We could have also said document here, but that doesn't necessarily make any sense. We wouldn't want a document to be a reader of another document. Maybe some use cases would. Or we can, in our type definition, we can also say that we want it to be a user or a document. And we denote that with the pipe symbol. So just to keep true to our example, we want only users to be readers of the document. The other thing to note about relations is that the naming should define the specific relationship that the subject has to the resource. So in this particular case, we're saying that the subject, the user, is a reader of the document. We like to keep reader, creator, owner, kind of that like ER, how the subject is related to the resource type. And now that we've defined the relation and the object types, we can actually go and write a relationship. So in the editor, in the playground, I can switch over to this test relationships tab. In the test relationships tab, we see this grid. You can think of it kind of like a spreadsheet, but it defines the resource part of the relationship, the subject part of the relationship, and caveats, which I'll get to later on in the video series. So just to create our example relationship, we will create an object type with a resource type of document. Here we'll call it quarterly planning. In a real system, this would often be a UUID or some kind of obfuscated identifier that means something to the application. But in order to make the example friendly, we'll use a friendly string. The relation here is going to be a reader. The subject will be a user. And then the user ID, again, this would often be some kind of subject claim or very long ID, but we'll just call it Jake to keep true to the example. So there, now we've got both the object definition with a relation type and the actual relationship that fits the schema laid down by that object definition. Okay, now we've got our two object definitions set up, document and user, and we've got a relation called reader between a document and a user. So the next thing we're going to do before we can dive any deeper into modeling is we're going to take the diagram that we've created so far of a single relationship, and we're going to convert it over to the way we generally model when we're dealing with permission systems in Excalidraw. So the first thing I'm going to do is take this single arrow that has the relation name in it, and I'm going to get rid of that, get rid of these things. Now I'm going to turn this from an instance of an object to the object definition itself. This is a user. And then this, if you remember from our model, was a document. And then the final thing is we take a relation and we express it using this diamond. The only thing that this makes easier is if we want to represent a lot of different outgoing types, we don't have to sort of type that text on every single arrow. So here we're going to say, and the other thing I guess that's different is that we draw the arrows from the resource outward. So here we're expressing, this was reader, we're expressing exactly what we were expressing before, but now we're doing it with this sort of data flow syntax. So you still read this as a user can be a reader of a document. But when we start walking through examples where we traverse the graph, you'll see that this notation is more useful because we always start from the resource-oriented side and we move toward the subject. So now that we've got our object definition set up, we've got a relation defined between our document and our user object definitions, we can start to finally talk about permissions. So permissions are the reason we're all here. What are the kinds of things that we can do? What are the kinds of questions that we can answer about a particular resource type? So switching back to the diagram here, I'm going to start to add some permissions to the document type. So I'm going to add a permission for view. That's a common operation against the document. Another one we can add would be update or edit. We'll call it edit. And then we can also add a permission for deleting a document. I know what you're thinking. Why no create? So the reason that we don't put create at this level is because we need to actually have a document ID in order to be able to ask these questions. So now I'm just going to draw an arrow between the resource type and the permission for that resource type. Just to say that they're associated with one another. And now expressing this in the playground would look like this. So in the playground, we're going to say permission view, and we're going to start off by having that expressed as nil. What nil signifies here is that we want to skip the computation, but it's totally valid syntax, and it's saying that no user or no entity of any type should be considered as having view permission on a document. Then we'll add our others, edit, delete. And just to recap, the type of question that we can ask is, can user Jake view document 123? So this is the type of question we can now ask, but we've deferred the computation. We've deferred filling in the computation for later. So now that we've got the questions defined, we can talk a little bit about how to actually resolve and how to figure out who can do those things. So we can start, we've got a reader relation already. And here we can say that the reader is allowed to view the document. But when we consider our other permissions, should a reader be allowed to edit a document? Probably not. Should a reader be allowed to delete a document? Probably not. So we're going to need a different kind of relation in order to be able to express those computations. So just quickly going back to our model, we're going to say that in order to be able to view, you need to have the reader relation, and that's going to go to a user. And so when we talk about walking the graph, what we're really expressing is that, actually I'm going to go ahead and delete these arrows because I don't think they add any clarity. And we'll go ahead and line up these permissions here under document. So what we're saying here when we are talking about walking the graph is if we think of these as edges in a graph, and we're trying to say, who can view a document? Well, we start with that document and that intent, the view, and then we can ask who are the readers of the document, and then we can say that those users should be considered as having the view permission on the document. Okay, and now for a slightly more complicated case, we'll add an owner of a document that's also of type user, and we'll go ahead and add the owner. We'll give the owner of the document rights to view, to edit and delete that document. So you might be asking, why didn't we just create a permission called own and say that it's the owner who is allowed to own the document? Well, the reason that we didn't want to do that is because we want the call sites in code that we integrate against this permission model to be stable. So if we want to change the computation underneath the hood about what it means to be able to edit or delete a document, we want the call site to stay the same. So we want the call site to still ask this kind of question, right? Can user Jake delete the document? Versus a question that maybe doesn't make any sense. Can the user own the document? What does it mean to own the document? So that's why we decide to have two permissions with the same exact computation. But there's a trick. So far, the owner is not allowed to view their own document. And we'll fix that up by talking about the operations, the set operations that we can do against these various relationships. But before we get into that, let's just make sure that our model stays in sync. So we have an owner, and then an owner is also of type user. That's what this means here. And then we're saying in order to be able to edit the document, you need to be an owner. And in order to delete the document, you need to be an owner. So now that we've got our basic model set up with some relations and some permissions, and we're computing those permissions in the most simplistic way possible, we can start to explore some of the operators offered by the SpiceDB schema language. These operators include the three algebra of sets operators that you might be used to. We have the union operator, which is represented by a plus sign. The intersection operator, represented by the ampersand, and an exclusion, represented by the minus sign. And to see how these work, we can actually use the playground itself to set up some examples. So the first thing I'm going to do is I'm going to add some relationships where we can set up a few more relationships for the common roles that we have. So I'm going to add reader 1, and I'm going to do reader 2 and reader 3. And then I'll do an owner of the document as well. We'll do 2 owners. Owner 1 and owner 2. Whoops. Let's go ahead and change these to owner. So now we've got 3 readers and 2 owners of the document. And now we want to see what SpiceDB is going to load for each of those relations directly. Now we can ask SpiceDB to compute this for us. In the expected relations tab, we can go ahead and we can say document quarterly planning reader. This is YAML, so if we just define it to an empty list and ask it to regenerate, it'll tell us who the readers are. And then we can do owner, define it again as the empty list. So now we see we have our 2 owners and our 3 readers. But remember, in our schema, we wanted view to include not only readers, but also the owners. So for this, we can do a union. So if you remember, this we can do a union. So if you remember from algebra of sets, the union of 2 sets includes all members of both sets. So now we can ask SpiceDB who is allowed to view this document. So we can regenerate. And now we can see that we have all of the owners and all of the readers. Okay, but let's find a use case for the other operators as well. So that's union. Let's try intersection and exclusion. So exclusion is an easy one. We can often do like a banned user, so someone who's not allowed to use the platform at all. So for that, we can do reader plus owner. And then here we're going to take that union and we're going to subtract out those users who are banned. So banned. Okay. And now we can see if we regenerate, nothing happens. But if we go ahead and we add a user, let's add one of the readers to the banned list. So let's say that reader 1 is now banned. Now we should see that reader 1 disappears from the view. Reader 1 no longer has view permissions on the document quarterly planning. Okay, you'll notice that it still does the union first before subtracting out the banned. So the order of operations here are similar to the math order of operations. So the plus and the minus are on equal footing. So functionally, what we've defined with parentheses would look like this. So it's the reader plus the owner minus banned. If we did instead owner minus banned first, because reader 1 is not a part of the owner group, and then we unioned that with reader, we should see that reader 1 pop right back in. Yep, so now they're back. So we'll just leave this in the clearest fashion possible. Right, and then so another way we could express the same thing, just for fun, would be that we could say that you are allowed to view if you are a reader or you can otherwise edit. We won't do that because there's a slightly subtle difference there with the way that banned is taken into account. So we'll just put it back to what it was before. All right, and then the last operator here to demonstrate is the intersection operator. Common use case for the intersection operator would be for like a boundary, like a permissions boundary. We're going to use it to say that a user signed the terms of service, right? So we want this to apply to all users, readers and owners and banned alike. So we're just going to wrap our existing computations, and then we're going to do an intersection with the signed terms of service. So I'll apply that to all of our permissions computations. Whoops. So now we've got uniform. And since so far there are no relationships, no users have signed the terms of service, we should see this go back to nothing. So view went to nothing, but reader and owner still, owner and reader. Oh, these are the owning and reading groups directly. So this is not edit and delete. So yeah, now we see that nobody has permissions to anything. And that's because when we intersect these sets, no matter how many users they have in them, with this set, which has no users, by definition, we're never going to get any users in our output set. So let's go ahead and have some users sign the terms of service. We'll have readers 1 and 2 sign the terms of service. Signed terms of service. Signed terms of service. And then let's have owner 1 also sign the terms of service. So now if we ask it to regenerate, we only get reader 1 or owner 2. We don't get reader 1 because reader 1 was banned. We get owner 1 in all of the places. So that's it for the basic algebra of sets operators. And they combine sort of exactly like you think they would. The last operator I'm going to talk about is the arrow operator. The arrow operator is written as an arrow, just like you may remember or may be familiar for pointer dereferencing from other languages. And the arrow operator allows us to load a set of relationships and use the subject of those relationships as an object for further computation. So just switching back to my editor, I've gone ahead and simplified the model a little bit just to make it more clear what the arrow is doing in isolation. And we'll go ahead and document that the arrow operator is expressed as a hyphen followed by a greater than sign, or just the arrow. And the arrow operator allows us to actually transition from one object definition to another object definition and continue our computation. Or we can even define a recursive relationship between one object definition and itself. So in our example, we've been dealing with documents, and a really natural extension point for documents is to create a folder that the document belongs to, and then inherit some permissions from the folder itself. So the first thing we're going to do is we're going to create a new object definition called a folder. And then we're going to add a relation coming out from the document. So starting from the document, and we're going to call its parent of type folder. Okay, so what this is saying is that a document belongs to a folder, or a document has a parent of type folder. And now that we've created this relation, we'll go ahead and fill in the relationship in our example relationships as well. So we're going to say document quarterly planning has parent, and this is folder. We'll call these planning. The folder will be called planning. Okay. So now we can go back to our expected relations and we can just verify that that's working as we expect. So we'll do document quarterly planning parent, and we'll ask it to regenerate. Some other things changed as well because I simplified the model and didn't regenerate, but you can see here that quarterly planning does belong, or does have a relation called parent to a folder, and that folder is called planning. So what can we do with this? We can start adding relations to the folder. So maybe we want the folder itself to have a reader and an owner. We'll define those as type user as well. Later on, we can extend this to be groups or other things, but for now, we'll have a folder, have a reader and owner. And then the arrow operator becomes very powerful because now we can say, for who can view a document, we want the document's direct readers and owners to be able to view it, but we also want the parent's readers and the parent owner to be able to view the document. Okay? And remember, in this case, the parent is a folder. So what's happening here, and we'll go ahead and we'll add some folder readers and owners. So we'll have an owner, user, folder owner 1. And then we'll have a reader, folder reader 1. Okay? So what's happening here is the arrow is telling the engine, is telling SpiceDB to first load all of the relationships that have the relation defined parent and that start from a particular object. So in this case, the object is document quarterly planning. So that loads this relationship right here. Then what it says is to take the folder planning and to use that as the resource side of a further computation, and to then load the owners, load the matching relationships, the owners and the readers for that folder. Okay? So we'll go ahead and we'll extend our other, our edit and our delete to include the folder owners as well too. Parent owner. So now that we've got all of our relationship or all of our permissions computed correctly, let's go ahead and ask it to regenerate. Now we can see that the folder owner is also allowed to delete, the folder owner is also allowed to edit, and the folder owner is also allowed to view. And the folder reader is also allowed to view the document as well. On top of that, remember how we skipped create when we were talking about our CRUD operations, create, read, update, and delete? That was because we didn't have a container from which to create it. So usually when you're creating a new document, you're creating it within the context of something. So in this case, we could add a permission create doc on our folder, and we could say that only the folder owner is allowed to create documents. And we can again go ahead and test that, where we can say folder planning, and then we want to do who can create a document. And now we see that the folder owner is allowed to create a document within that folder. And that's it for the arrow. So the arrow is very powerful, and the arrow lets you basically continue this type of traversal to sort of arbitrary lengths. The final major building block that I'll cover in our journey are caveats. So caveats are a way to inline small amounts of attribute-based access control in a very relationship-based access control or reback native way. And the way caveats work is they make a relationship conditionally present. So heading back to my editor, what I mean by conditionally present is we might want a relationship to sometimes act as if it exists and sometimes not act as if it exists. So I'm going to come up with a very contrived example for when you might want to use a caveat. But I'm going to say for this contrived example that I'm going to add a new relation to document. And that relation is going to be called auditor. And that auditor is also going to be of type user. And I'm going to say for whatever reason that auditors are only allowed to audit on Tuesday. Or this auditor is only going to be an auditor on Tuesday. So in order to define on Tuesday, I'm going to create a caveat. So here I'm going to create a caveat, and the caveat is going to be called day of the week. And we're going to accept one parameter. Actually, we'll accept two parameters to day of the week. We will accept the requirement parameter, and that'll be of type string. And then we will accept current day of week, and that will also be of type string. Caveats in SpiceDB are defined as cell expressions, CEL, the common expression language. And here I'm going to say that the expression for this caveat is that the requirement must equal the current day of the week. Okay, so that's it. That's defining the caveat. But in order for a caveat to take effect, we need to have the caveat actually referenced in our relationships. So what we're going to do is we're going to go back to our auditor relation, and we're going to add a caveat. And the way we express that this requires a caveat is that we say with day of the week. So now this relation is going to require us to express a caveat as well. So going over to our test relationships, we can add a document quarterly planning. We always do this quarterly planning. And we're going to add a relation for auditor. And we're going to say that the auditor is of type user. We're going to say the auditor. You'll notice that this is still highlighted in red because we have to actually have the caveat defined as well. So I'm no good at remembering the caveat syntax off the top of my head. So we're going to flip back over to the grid editor to add this. So here we can go into the auditor, and then here we can say that the caveat name is going to be day of the week. And then for the context are the values that get passed into this expression. So in this case, we have two values that we can pass in. And we have two opportunities to pass in those values. We can store some of these values alongside the relationship. We're going to do that for our requirement, right? So the auditor requirement is only going to be stored once with the relationship. And then we're going to pass in the current day of the week at request time. as a different kind of context. So back to our test relationships, we have the context here. This is a JSON blob functionally. So here we're going to say that the requirement is Tuesday. Okay. So now we've got the context set up where we've got the requirement for Tuesday set up on the day of week caveat for the auditor. So now if we go back to our, the last thing is that we actually have to use this auditor role. The auditor will only be allowed to read. So now the auditor, if we go back and we regenerate our permissions here, we see, I'll just get rid of some of this other stuff as noise, but we see that the auditor has these triple dots after it. What this means is that based on what context we pass in with the request, sometimes the auditor will be able to view the document and sometimes the auditor won't. And we can actually test this with an assertion. So for our assertion, we're going to set this up with the minimal. This is a list of assertions, and we're going to say that, and these are also expressed in sort of the relationship format. So we're going to say that quarterly planning view for the auditor, user the auditor, and then I can barely ever remember the syntax for this, but I believe we pass syntax this way. And we're going to say that, what was the name of the parameter? It was current DOW. So we're going to say that current DOW is Tuesday. Okay. I've apparently made a mistake because of the syntax highlighting. That's what it is. I don't use brackets, I use the word with. So now we no longer have the error, and when we run our assertion, it's true. But we can also assert false. First, let's run this and make sure that it fails. Yep, it's failing. But if we change this to Wednesday, now we can see that they both assert the same way. So we've shown that on Tuesday, the person is considered an auditor, and on Wednesday, the person is not considered an auditor. We can do these same kinds of computations with numerical values. So we could define these as integers, and then we could compare them, or floating point values. Or we can use things like IP addresses and dates to make sure that users are only allowed access from a particular location or on a particular date. So this is a very powerful construct that we can use to bring in very small bits and build up what I like to call just enough policy to be able to make the correct decision at all times. The next thing I'll talk about in the SpiceDB schema language is a very small addition that was made for a very specific purpose. So the name of this feature in the schema language is called a wildcard relation. And so what a wildcard relationship allows us to do is it allows us to do patterns like make an object public. So heading back to my editor, it's possible that we want to say that some document is readable by any user, not just the specific named users. So in order to add that, we're going to add an alternative subject type for a document, and we're going to say that the subject type is user : star. So this is a wildcard, and as I mentioned, it will match any user that actually gets passed into the system as a user object. Even though we've defined this on the schema, that doesn't make all documents automatically public. What else we need to do, or the next thing we need to do, is we need to write a relationship that will specifically make one document readable by all users. So we're going to make a new document just for the sake of this example, and we're going to call this document example public doc, and we're going to say that the readers of the example public doc are user : star. So we want all users that can identify as a user subject type to be able to read this doc. So if we go back to our expected relations and we create a new version where we say example public doc, we define this as the empty list. We should expect it to show us all of these users, but it doesn't. And the reason that it doesn't is because loading up all of the users, trying to find all of the users in the system is actually somewhat nonsensical for relationship-based access control, because our relationships are only defining edges. We don't have an exhaustive list of all of the users of the system. But to test this with one particular user, we can use an assertion. So here we can go say that we want to make sure that user reader 1, user:reader 1 has read access to the document. So if we run that, sorry, that's quarterly planning, we want example public doc. So for example public doc, we note that the user does in fact have read access to the doc. Just to make sure this isn't some kind of wacky aberration, we can change this to, folder planning, right? So we want to make sure that folders don't have view access to the document. Yep. So as expected, that fails, but reader 1 works. Now the reason I said it's nonsensical for it to list out all of the possible users is because we can make assertions about users here that have never been seen by the system before. So this could be like an anonymous user or an unregistered user. And those will still also pass, even though there are no other relationships in the system that references this username. The next feature that I'm going to talk about is called subject relations. Subject relations are actually mentioned, they're cited in the Zanzibar paper, and subject relations allow us to perform a function very similar to an arrow, but to hoist the decision about whether to perform that arrow, to walk that traversal, into the data plane instead of defining it as a schema. And I think this is best explained with another example. So I've gone ahead and reduced this, this example back down to just a simple document and folder hierarchy to keep things clean. But what we're going to do here is we're going to add a new definition called groups. Groups should be a very familiar concept. Something like Google Docs has it, where you can belong to a group and then you can share a document with a group. And in fact, that's exactly what we're going to use to model here today. So within a group, I want to have a relation to members of the group, and that's going to be of type user. Okay, so we can go ahead and we can set up a group in our test relationships and say group, I don't know, engineering. And then we can say the users, members of the group, this should just be member. The members of the group are user engineer 1 and engineer 2. Okay. And so now what we have is we have a group, and the group is sort of floating off on its own. It's disconnected from the document. If we go back and we regenerate, we see that there's no engineers listed as viewers of our quarterly planning doc, but we're going to go ahead and give that group reader access to our document. So we're going to start by extending our reader relation to say that it can also take groups. And what we could do now is we could write a simple relationship where we could say that, I'm just going to delete these, where we could say that document quarterly planning as reader of group engineering. Now, you might expect in our expected relations that engineer 1 and engineer 2 would show up as readers. But what's happening here is that we've got a type mismatch. So here we've got users who are the terminal object. Those are the users that we're asking questions about. And then we've got groups, and we've got them set up as peers. What we could do is we could attempt to walk, right? So we could say reader or reader member, and this would get us our desired result. So if we regenerate, we get our engineer 1 and our engineer 2, but we also still have the raw group object. And now we've opened up a potential hole where if we add a relation on user called member, whatever we define this as is all of a sudden going to start getting picked up by view. So what we want to do is we want to reconcile the types. We want to make sure, we want to make sure that all of the readers are of type user when they're fully resolved. And the way we're going to do this is we're going to use a subject relation. And we're going to say that rather than making a group readers of the document, we're going to make a group's members reader of the document. So this has a functional difference, and it's a different thing that we're trying to express. We're no longer saying that the group is a reader. We're saying that the members of the group are readers. And so here we can no longer traverse into member because reader, neither of these things, users don't have members and users don't have members. So these are now both of type user. And then in our test relationship, we have to actually express using an optional subject relation that it's the members of the group that are readers of quarterly planning. And then if we open up our relationship grid, we can see that those show up as the subject relation. Now, if we go over here and we ask SpiceDB, who are all of the people who have view on the quarterly planning doc, we see that now the members of the group have the read access to quarterly planning, and fully resolved, that's engineer 1 and engineer 2. So this is usually the correct way to take one of these decisions that could have been a schema time decision if we were doing reader member, and move that into the data plane where we make the decision, we, the relationship writer, makes the decision about the type and how we should continue to descend into this object when we're doing our group resolution. Well, I hope you've learned a lot about SpiceDB schema language and how the various building blocks can be composed together to build up a permission system for your specific application. Stay tuned for future videos where I'll cover some of the patterns that we're seeing emerge and some of the patterns that we've designed with the help of our users and customers for higher level concepts in applications. And also stay tuned for another future video where I'll teach you how to do modeling for your own application while keeping in mind the performance impact of various design decisions in the schema language. Thanks for watching.